Hey, so this is just a quick video. I'm going to try and use my built-in microphone on my Mac laptop. I'll also use a strobe on my iPad just so you can see it. So I have this piece of spruce here. I have made it rectangular and I have sanded it so it's flat. You can see I already drew in the spots so I don't have to measure them, right? And I've already weighed it. The first measurement I want to get is the long grain. So from here to here, the way to think about this is just like a string has harmonic points, a plate has harmonic points. The string's harmonic points, we're used to them, like the first one's at the 12th fret. Well, on a plate, it's at 22.4%. So that's about here, and it vibrates in the middle. So I'm going to hit it here. I'm going to hold it here, and I'm going to touch it. Let's see if I can get this a little better here. Hold it here, and I'm going to pluck it here. Right? Hopefully that's coming through. So now I'm going to show you both with the strobe tuner and with my FFT just to kind of see the frequency. Sorry, I got to log into my tablet. So now I'm going to change this so you can see this here. I'm holding it in the same spot I just was. Okay. 76.5-ish hertz. That's the long grain. And now I'm going to show it to you on my laptop doing the same thing. So it's using the Mac built-in microphone. I'm going to hit record, click through the error messages, holding it in the same spot. Click stop recording. 76.6, almost the same number. So I'm going to click it and leave it. So that's the long one. I'll get the diagonal one next. So this is the transverse. So for this one, I'm going to hit here and hit it down here. So hold it, pinch in the middle, hit the lower corner. You can kind of hear two notes. We actually want the lowest pitch note. So first I'll try and capture it on the strobe tuner so you can just see the frequency. So it's saying 219, but that's not the right one. We got to get the lower one. This one is the easiest to mess up and the easiest to miss. See, I don't know if you saw it at 44. So now let me catch it here. Stop recording. Okay, that was a little bit too high. I clicked in the wrong spot. You can also see that there's actually a peak here at 76. That was kind of a miss. They'll often show up. It's not a misclick, but they will show up in the other things. But I want to catch the 44 number that we were seeing in the strobe tuner because I just... There we go. So 46.88. It's close, right? And then the third one that we want to get is the cross grain. So that's the one across this frequency, right? I'm going to hold it at 22.4% this way, and then I hold it down a little bit because what I'm trying to do is mute the long grain frequency, right? So this is a spot where it's here, but it's in the middle of this. So you can hear that here. See, it's 135.5. When I hit record again on this, hit stop recording. There you see the number 136.41. Now I'm going to turn this here. So now I go over to the other tool, the plate thickness calculator. You can see that I've actually already kind of pre-filled this. So for the length of the guitar box, the lower bout width, I've already weighed this. It weighs 190.6 grams. The panel height is 4 millimeters. Right, I'll take my caliper and kind of find whatever the minimum number this says, right, and do it in a few spots and average it. The panel width is 219 millimeters, right, and the long grain frequencies, again, I've already typed them in, but the ones that I measured this time were 76.6, 46.8, and 136.4, right? And so here I had 76.5, 136.28, and 44.2. I'm actually going to type in the other numbers that I measured just so you can see what kind of difference it makes. So with these numbers that are already in here, I got a target thickness of 2.67 millimeters. The other really important thing about this is because this is the top I got at Pacific Rim Tonewoods. It's got the sticker, so you can see the two numbers here. First is the density at, sorry for making it blurry, 394.8. And then the long grain Young's modulus here at 12,551 megapascals. So you can see here my density is 399, so it's almost the same. It's within one-ish percent, and the Young's modulus across the grain, this is about 2% different. So I measured 12.15 gigapascals. This is 12,000 megapascals. It's very close again to the same number. So now let's type in the new frequencies that I measured this time, just so you can see how it changes. So 76.63, 46.88. So this number is different than what I had measured before. I think the 44.2 number is actually right. And then the third number is 136.4. Right, and so then the last important number here is the target frequency. So what this number is what frequency on the long grain do you want the wood to be when it's at the target dimension? The default is 75 hertz because that's in Trevor Gore's book, what he said he worked to, right? So when I put in these slightly different frequency numbers, let's see how this changes. So it goes from 2.67 to 2.66 millimeters. It's 1/100th of a millimeter. As long as you get the numbers close, you'll get pretty close to the right number. In practice, it's actually pretty hard to thickness something exactly to 0.01 millimeters. And we know that when you finish your box, you're going to sand it down more anyways, right? So it's really about a target and being, close, maybe a smidge thicker than that. What can happen though is if you get these numbers too high, it'll tell you to make it scary, scary thin. So if you're not seeing a target thickness that makes sense, like 2.6, 2.7, 2.8, 2.5, then really question the numbers. I hope this helps.